Back in July 2025, astronomers stunned the world with the announcement of a new cosmic discovery. Comet 3I-Atlas, the third interstellar object ever spotted. Since then, it hasn't stopped surprising us. New observations show it to be much larger and heavier than anything we've seen from beyond our solar system, sparking passionate debates among scientists. What makes 3I-Atlas so extraordinary, and why could it change the way we think about interstellar visitors? Let's dive into the mystery. The story began on July 1, 2025, when the Atlas telescope in Chile picked up a strange object streaking across the sky. It wasn't moving like a normal comet. When astronomers traced its path, they realized it wasn't bound to the sun. It was traveling on a hyperbolic trajectory, meaning it had come from far beyond our solar system. In that instant, 3I-Atlas was added to a very short and prestigious list alongside the cigar-shaped Oumuamua and the icy traveler 2I Borisov. But each of these cosmic guests has been different, and 3I-Atlas is no exception. Early estimates suggested its icy core was about 5.6 kilometers wide, bigger than Borisov. But its size wasn't the most shocking detail. What truly puzzled astronomers was how it moved under the influence of sunlight and gas jets. Here's the thing. Comets aren't just frozen rocks, they're active, dynamic bodies. As the sun heats their icy surfaces, gas jets burst out like tiny thrusters, pushing the comet slightly off its gravitational path. This effect is well understood, but when we apply it to interstellar comets, the results have been puzzling. For Oumuamua, the effect was unexpectedly strong, leading some to speculate about strange explanations. For Borisov, the effect matched predictions perfectly. So what about 3I-Atlas? Teams across 227 observatories worldwide tracked it between May and September 2025. They clearly saw the outgassing, streams of dust and gas venting into space, yet the comet's orbit barely budged. The deviation from pure gravity was so tiny, less than 15 meters per day squared, that it baffled researchers. How could such an active comet behave as though it weighed far more than expected? After running the numbers, scientists concluded the nucleus must be astonishingly massive, at least 33 billion tons. To put that into perspective, that's vastly heavier than Borisov, and even Oumuamua's estimated mass pales in comparison. While it's still not as gigantic as the monster comet Bernardinelli-Bernstein, for an interstellar traveler, 3I-Atlas is truly exceptional. And here's where it gets even more fascinating. According to existing models, interstellar space should be filled mostly with tiny shards and fragments, leftovers from the birth of alien solar systems. These small pieces should vastly outnumber the giants. By that logic, our first discoveries should have been modest, unimpressive chunks of ice. Yet what have we found instead? A mysterious cigar-shaped enigma, a surprisingly active comet, and now a colossal heavyweight that defies the odds. It's no wonder astronomers keep calling 3I-Atlas an anomaly, not because it seems artificial, but because it doesn't match the expectations we built from decades of theory. It's as though the universe is reminding us, once again, that every answer only opens up more questions.
So far, every interstellar visitor we've caught has been surprisingly large, and of them all, 3I-Atlas stands out as the heavyweight champion, over 5 kilometers wide and far denser than we'd ever imagined. Statistically, that's strange. If the galaxy is filled mostly with small fragments, then stumbling upon a giant this early feels like rolling the dice and hitting the jackpot on the very first throw. That's what has scientists scratching their heads. But its size is only the beginning. 3I-Atlas is chemically different too. Observations from the James Webb Space Telescope show it's loaded with carbon dioxide, far more than most comets we've studied, putting it among the most CO2-rich ever found. Even when it was far from the sun, ultraviolet instruments caught it venting water vapor, something ordinary comets usually don't do until they get much closer to the heat. Then there's its dust. Using polarization, astronomers studied how sunlight scatters off its grains and found a pattern unlike anything seen in solar system comets or asteroids. It suggests that the dust may have a different structure altogether, perhaps a fingerprint of the alien system where it was born. Early measurements even hinted at nickel without iron, a pairing almost unheard of in natural chemistry. Was this a fluke in the data or a genuine anomaly? Either way, it added more fuel to the fire. Unsurprisingly, the speculation took off. Harvard's Avi Loeb has argued that if these mass and composition quirks hold up, natural explanations might not be enough to explain them. Others, like NASA's Tom Statler, urge caution, reminding us it looks and acts like a comet. Yet the contradictions refuse to go away. Are big interstellar objects actually the norm? Or are the smaller ones simply slipping past our instruments unnoticed? And while scientists debate, the show is unfolding in real time. As 3I-Atlas barrels towards the sun, we're about to see how a massive interstellar comet handles the stress of solar activity. In late September 2025, a coronal mass ejection from the sun was predicted to collide with it. If so, astronomers may have witnessed a dramatic disruption in its glowing tail, just like what happened in 2007 when Comet Encke's ion tail was snapped off by solar wind. Such an event would be brief, but historic, since no interstellar comet has ever been caught in such a cosmic crossfire. The real climax comes on October 3, 2025, when NASA's Mars Reconnaissance Orbiter and its HiRISE camera will try to capture high-resolution images as 3I-Atlas swings close to Mars. Then, frustratingly, it will vanish behind the sun for 2 months, hidden from Earth in solar conjunction. When it reemerges in December, astronomers will be ready, eager to watch its activity surge at its brightest phase. But the bigger picture goes beyond just one comet. The Vera C. Rubin Observatory, now scanning the heavens nightly, is expected to change the game. In its very first hours of operation, it discovered thousands of new asteroids. Over the coming years, it could catalog countless more interstellar wanderers, finally giving us the sample size we need. If 3I-Atlas turns out to be part of a hidden population of giants, then our theories of planet formation and how other star systems eject comets may need rewriting. If it's a rare outlier, then its discovery so soon may expose blind spots in our methods or biases in our data. One thing is certain, 3I-Atlas will not return. This is our one chance to study it up close, to peel back the layers of mystery and glimpse how alien comets form and evolve. Massive, strange, and utterly unmissable, it is only our third interstellar guest, but perhaps the most important one yet. As it nears the sun, astronomers will be watching every move. And if you care about humanity's place in the cosmos, so should you.